Write that down here.
Actually, it's a 2 by 3.
Mr. Terrell, let's write this down as a 2 by 3 because there's 2 rows and 3 columns, right? And this is a 2 by 2. Notice something here. The key to this lesson is row times column, right? But what if I take this row, which has 3 terms in it, and I put it on top of this column? Okay, that's not going to work here. All right, so what we're saying here is that this row goes on top of that column. I can't put 3 numbers on top of 2. So this one has no solution to it. Because I have 3 numbers, I can't put it on top of 2 numbers. How can we say that? This is what tells you how many numbers are in each row, because there's 3 columns. This is what tells you how many numbers are in each column in the second matrix, because there are 2 rows. These numbers right here must match in order for this to work. And since my numbers do not match in this problem, that's the reason why we have no solution. Does that make sense to you?
Yes.
Okay? So what we should say here is this. Inner dimensions must, capitalize, be the same. They must be. And if your inner dimensions are not the same, your answer is not possible, Mr. Hilligoss.
Could it also be outer and you just flip-flop the 2?
Yes, but this times this is not the same as this times this. Okay, now let's try this. Let me give you a new one, we'll see what happens here. Okay, give me a 3 by 2 matrix. 2, 3, 4, -1, 0, 6. Multiplied by 4, 5, 3, 2, -1, 0. Now, unlike adding, okay, it doesn't seem like that these would be able to be multiplied together, does it?
No.
This is pretty ridiculous. But let's see, let's examine the dimensions and see what we can get here. This is a 3 by 2. This is a 2 by 3. Is this possible?
Yes.
Yes, because the dimensions on the inside are the same, and that's good. Guess what? The dimensions on the outside, 3 by 3, give you the dimensions of what your answer is going to be. Think about it this way. When I start off with the top row, how many terms are in the top row? 2. And if I multiply it by all 3 columns, that's going to give me 3 answers. I have row times column, column, column. Second row times column, column, column. There's 3 more. Third row times column, column, column. There's 3 more. So the outside dimensions is going to tell you that now I have a 3 by 3 left to find. Okay? Let's just quickly go around the room. If you don't know it, say pass. France, what goes first? Row times column. That would be what?
14.
That's correct. Anybody else think 14 in their brain? Okay. Let's think about why. Well, the 2 goes on top of the 4, which is 8, and the 3 goes on top of the 2, which is 6, and 8 plus 6 is 14. Okay, Midori, what's next?
7.
7 is correct. Why? 2 and 5 is 10. The 3 goes on top of the -1, and that's -3. And 10 and -3 is 7. Mr. Noyce, last number in the top row?
15.
Okay, row times the last column there. See that? That would be a 6. You see where I'm at?
Yeah.
And then that would be a 0. So 6 and 0 is just 6. Okay? Now, the first row is done. Check mark. Okay, Tate, let's move to the next row. First column. See how whichever ones you multiply together tells you where your answer is going to be? Second row, first column is going to be the second row, first column number, which goes right here. Which is going to be what? 14 is the correct answer. Okay. Issue, how about second row, second column? It would be 21. Nice job, because that's 20 plus 1. Mr. Terrell, second row, third column.
0.
Close. Think again. You do have a 0 somewhere.
Oh, I did that.
Oh, you were doing last row, third column, weren't you? So we're still in the second row, third column.
12.
12, thank you. Okay. Mr. Thurlow, last row, last column.
Is that, wait, last row first?
Last row, first column. What's wrong with me?
Is that 12?
12 is correct. Mr. Jacobs, last row, second column.
-6.
-6. And last row, last column, that would be Kaylee Pugh.
0.
0 is right. Is this making sense to you?
Yes.
Can you see how it's a little bit more time consuming?
Yes.
A little bit more mental math? Okay, you can stop the video.